last section had us simplifying radicals and square roots and making irrational numbers into simpler forms. Today's video is going to be covering something really specific with irrational numbers called rationalizing the denominator. And so as soon as you see denominator, it tells you we're going to be working with some fractions, because the denominator being the bottom of a fraction, and rationalizing is going to be getting rid of the irrational number. So as a quick review, rational numbers are numbers that can be made with fractions, with whole numbers. This also means any decimals, integers, or percents. So basically anything that you want to be working with rational numbers. Irrational, by extension, for us really only have one specific example. So that would be non-perfect squares as square roots. So irrational numbers are decimals that never end or repeat. So that would be something like the root of 10. If that we actually wrote that as a decimal, would never end or repeat. For contrast, square root of 16 is equal to 4. Therefore, the decimal does end. Therefore, rational number. So as we are working with these problems, we're going to do a quick review of simplifying radicals. And what we're trying to do is turn this irrational number into a simpler irrational number. And we always are looking for the largest possible perfect square, which in this case would be 16. Therefore, we can convert the square root of 48 into the square root of 16 times the square root of 3. We know that this number turns into the number 4, and this irrational number is going to just stay. Therefore, we have 4 times the square root of 3 is the same as the square root of 48. So we have the same number, but written in a simpler form. But what about if we have our number of the square root of 48 inside of a fraction? So we have the square root of 48 over 27, the whole number underneath a radical symbol. So we remember from above, we had 4 times the root of 3 as the top of our fraction. And I want to note one thing. If I have a fraction underneath a radical, I can rewrite that as each part of my radical like this. So when I'm seeing this problem, I'm seeing this problem at the same time. So for example, the top problem once again is 4 times the root of 3. And now I need to simplify the root of 27. Well, the largest possible perfect square is 9. So I do the square root of 9 times the square root of 3. Square root of 9 is the number 3, and this is going to stay. Therefore, the bottom of our fraction is 3 times the root of 3. But hopefully I notice that because I have the same number in the numerator and denominator, I can get rid of this and replace it with the number 1, because any number divided by itself is equal to the number 1, so my answer is just 4/3. Now for this problem, there's actually another strategy that would be even faster. And if I think about just the fraction underneath the radical symbol, I can actually simplify that fraction right away by dividing both of these numbers by 3. 48 divided by 3 is 16. 27 divided by 3 is 9. Square root of 16 is 4. square root of 9 is 3. And we are done. And we got the same answer both ways, but the strategy on the right was actually substantially faster. So for SPs in this video, you need to come to me and say that when you have fractions underneath a square root symbol, you should simplify the fractions first. And you do that, you'll get 5 SPs. So let's do another example, and I'm going to show you both ways. So I'm going to show you the way where we simplify the fraction first, and I'm going to show you the way where we don't simplify the fraction first, and show you get the same answer, but one is faster than the other. So on the left side, I'm going to simplify the fraction first. And I know that 8/24 can be simplified by dividing both of these numbers by 8, which gives me square root of 1 over the square root of 3. Well, the square root of 1 is equal to the number 1, and the square root of 3 is done. So we are done with simplifying this problem, except that this video is called Rationalizing the Denominator. And what we have is an irrational number in the denominator. And in mathematics, you always want to try to avoid having an irrational number in the denominator. So there is a very specific strategy on how we get rid of the irrational number in the denominator. What we do is we are going to multiply this times the number 1. But that doesn't actually help us unless we remember that if we multiply the square root of 3 times the square root of 3, we end with the number 3. And our denominator is no longer an irrational number. This right here is the number 1. Our top of our fraction is 1 times the square root of 3, which is just the square root of 3. So before we had this number, and now we have this number. And the difference is the one on the right does not have an irrational number in the denominator. So we call that rationalizing the denominator. And this time, this strategy is actually necessary to solve this problem. But let's solve the same problem without simplifying the fraction right away and see if we still have to rationalize the denominator at the end. So 8 turns into the square root of 4 times the square root of 2. 24 turns into the square root of 4 times the square root of 6. Well, we can get rid of both of these because they're equal to 1, and so our answer ends up being the square root of 2 times the square root of 6. Once again, we have an irrational number in the denominator, so we have to rationalize the denominator by multiplying square root of 6 over the square root of 6. The problem we have here is that this doesn't actually help us a ton with our problem. We end up getting this, which we know our answer is down here. So it means that once again we have to simplify. So it's like starting over. This becomes square root of 4 times the square root of 3. On the bottom we end up getting 6. This turns into the number 2. And we finally get down to the same problem we had before. But once again, this was a lot more work. So as a reminder, simplify the fractions first. It's going to make your life so much easier. As we work on our last problem of this video, we see our fraction is already broken up, and we can't simplify the irrational number on the bottom. I do know that the square root of 4 is equal to 2, so I can write that right away. But once again, even though it looks a little strange because I have 2 numbers on the bottom, I still have an irrational number in the denominator. Now, last time we multiplied times the radical. This time we're still multiplying times the radical. You are not multiplying times the rational number, only the irrational number. So I'm going to multiply the numerator and denominator by the root of 5, because once again, this is equal to the number 1. Multiplying by 1 won't change the problem. I also know that 2 divided by 2 is equal to 1, so I can ignore that for the rest of this problem. Now I get the square root of 5. Square root of 5 times the square root of 5 is 5. And now I have no irrational number in the bottom. I can't simplify my radical anymore, and my answer is done. So this is not an easy concept, but remember, the only thing that's different is you need to simplify your fraction first, and you need to always rationalize your denominator. You cannot have irrational numbers in your denominator. As always, if you have questions, please let me know.